Hey everyone, and welcome to this explainer. Today, we're diving deep into Chapter 9 of the Developer's Guide to AI, and we're tackling a really critical decision that pretty much every AI developer eventually faces: upgrading your applications. We're going to explore exactly when and why you should move way beyond basic AI prompts and step right up to true enterprise-level integration. Because let's be honest, if you've ever felt like your AI is just kind of missing that specific specialized edge, you are absolutely in the right place.
So here's our roadmap for today. We're going to quickly cover the limits of standard models, the customization hierarchy, building versus fine-tuning, strategies for fine-tuning, catastrophic forgetting, and finally, exactly when to use which approach.
All right, let's jump right in with Section 1, Limits of Pre-trained Models. I want you to start by asking yourself a really fundamental question. When is a prompt just not enough? I mean, think about the friction points in your own day-to-day development workflow. Now, for most generic tasks, modern AI handles the requirements with absolute ease. But as developers, we constantly hit that frustrating wall where generic, pre-trained models start to fail in specialized, real-world enterprise environments.
Now, don't get me wrong, out-of-the-box large language models are incredible. They excel at general, task-agnostic skills, whether that's drafting a quick email, summarizing a super dense financial report, classifying unstructured data, translating languages, or even just acting as a helpful chatbot. You can usually achieve excellent results using just basic prompt engineering. These models are amazing precisely because they adapt to all these diverse tasks with absolutely no retraining required. They are literally the ultimate generalists.
But then we hit what we call the inbox problem. Imagine a startup, right? They're using a standard retrieval augmented generation, or RAG, setup. Basically, they're giving the AI an open reference book to answer website support questions based on their own company documents. And it works wonders for general inquiries. But suddenly, they decide to move to a more practical application, automatically drafting actual replies to incoming customer emails. Well, that basic setup completely fails. Why? Because the model now needs to genuinely represent a highly specific brand voice and adopt a specialized niche capability. It has to know exactly how your company speaks, not just how the broader internet speaks.
Which brings us to Section 2, the model customization hierarchy.
Think of the model customization hierarchy like a ladder that we're building from the ground up. At the very base, you have prompt engineering. It's cheap, it's easy, and it is always where you should start. Next rung up is context engineering, or RAG, which grounds the model in your specific documents. But when those just aren't cutting it, you move up to fine-tuning, where you actually alter the model's core capabilities. And finally, sitting all the way at the very top, for when you need absolute uncompromising precision, is building a custom model. The higher you climb up this ladder, the more focused and precise your AI becomes, sure, but the time and the expense, they increase dramatically.
And that leads us perfectly into Section 3, Building versus Fine-Tuning. Let's be real for a second. Building a new foundational model from scratch is a massive, massive operation. To pull it off, you require an enormous amount of data, mostly harvested from the vast expanse of the internet over months and months of scraping. It demands immense computational resources, incredibly expensive GPU clusters, extensive infrastructure, and frankly, really deep technical expertise just to get to a publishable state. It is a profoundly heavy lift that is simply way out of reach for most standard development teams.
So, when we directly contrast these two approaches, it reveals a really clear trade-off. On one hand, building a new model gives you complete control over the architecture. You get absolute customization without relying on any external dependencies. But the cons are huge. It's incredibly computationally expensive and time-consuming. On the other hand, fine-tuning takes an already powerful pre-trained model and just molds it to your specific needs. Yes, you sacrifice some architectural control, and you do run the risk of inheriting the original model's biases, but it requires significantly less time and far fewer resources. For the vast majority of working developers out there, fine-tuning is exactly where you want to be.
Okay, let's talk about how we actually do this in Section 4, Strategies for Fine-Tuning.
I love this analogy from the chapter. Think of fine-tuning as giving a small, specialized tool the perfect edge for a specific job. A massive, blunt, general-purpose AI tool might be able to handle a niche task eventually if you prompt it hard enough, but a smaller, fine-tuned tool is infinitely more efficient. It's precise, it's easier to handle, and crucially, it is so much more economical to run in a production environment at scale.
To kind of demystify how this actually works, let's look at supervised fine-tuning.
Honestly, this is basically teaching with flashcards. You provide the model with a specialized data set where each piece of information is paired with a corresponding label, or the expected answer. For example, if you want the model to write medical summaries, you feed it thousands of examples of raw clinical notes paired with the perfectly written summary. Through this repetitive, flashcard-like process, the model absorbs the subtle nuances, the specific tone, and the unique style of your data. Instead of trying to guess what a good summary looks like based on its general internet training, it starts knowing exactly how you specifically want it to respond.
But it's not all smooth sailing. Let's look at Section 5, Beware of Catastrophic Forgetting. Before we tackle the danger, we have to understand what is physically being altered inside the model during this process. We're talking about model weights. These are the numerical parameters inside a neural network. As a model originally trains on massive amounts of data, these billions of numbers are minutely adjusted. Collectively, these weights represent every pattern, every grammatical rule, every feature, and literally all the foundational knowledge the model has ever acquired. They dictate exactly how the model processes your input to generate a coherent output. So when you interact with a model, you're essentially passing your prompt through this incredibly complex, delicate web of mathematical weights.
And here is the 1-2 punch. When you fine-tune, you are adjusting those exact weights. And if you adjust them too aggressively, you trigger a phenomenon called catastrophic forgetting. This is a massive, high-stakes risk where sequential learning on a new task causes the model to abruptly or severely lose its ability to perform the previous tasks it was originally trained on. The new learning physically overwrites the model's existing foundational knowledge. Think about it. You might successfully teach it your company's highly specific brand voice, but because the foundational weights were scrambled, it suddenly forgets how to formulate a basic, grammatically correct sentence. Your highly specialized tool just became entirely useless for general operation.
So how do we navigate this? Let's break it down in Section 6, When to Use Which. We can really boil this down to some sharp binary contrasts. Just remember this golden rule: better data beats bigger prompts. You should reserve fine-tuning for when you absolutely need the highest possible performance for complex tasks that require deep in-domain knowledge. And, this is key, when you actually have the high-quality training data to pull it off. Fine-tuning embeds the knowledge into the model itself. Conversely, stick to prompt engineering when you have limited resources, you're dealing with simpler tasks, or you just need a quick, reliable solution without messing around with the model's internal weights. Sometimes a well-crafted prompt is genuinely all you need.
But this leaves us with a pretty critical dilemma. If building a model from scratch is way too expensive, and traditional fine-tuning risks catastrophic forgetting while still requiring significant compute power, how on earth do you fine-tune without breaking the bank?
Well, the answer lies in the modern hero tools of our story: PEFT, which stands for Parameter Efficient Fine-Tuning, and LoRA, which stands for Low Rank Adaptation. These are the cutting-edge strategies that allow developers to economically fine-tune large language models, gaining that specialized edge while carefully sidestepping the dangers of catastrophic forgetting. They actually do this by freezing the original model weights and only training a tiny fraction of new parameters. It's brilliant, but knowing this exists raises a brand new question for your workflow. Which of your company's generic, clunky AI tasks is secretly waiting to be transformed by a PFT integration today? Thank you so much for joining me on this explainer, and happy coding!